Hi there, this is Bob from INSYDIUM. In this tech preview, we'll show you the massive improvements made to the NeXus GPU Core. It's been stripped down and completely rewritten in our quest to make NeXus faster, smarter, and more efficient than before. Particle simulations in general are quicker, use less VRAM, and the whole system provides a smoother artistic experience. There are new features and improvements to the global NeXus tools. GPU Falloffs can be used within NeXus modifiers for efficient, fast control. Data mapping can be applied per layer, and NeXus Question has many updates including variations and more sophisticated advanced particle neighbor searches. So, loads to show you. Let's start up Cinema 4D and we'll have a look. Let's start by doing some speed comparisons then between the current release build of NeXus and the brand new version with the new NeXus Core. So we'll start with this fluid scene, and there's a lot going on here. We've got a fluids, we've got a vorticity, we've got a rotate modifier as well, and then we've got particle to geometry collisions with the cylinder and all of these quite highly detailed rocks as well. So a lot going on. What we'll do is jump into our comparison page and let's have a look. So on the left is the current NeXus GPU Core. These will be the blue particles. And then on the right, we're going to play back the simulation test on the brand new core, which will be part of INSYDIUM Fuse 2025. These are being played back at 4 times the normal speed. This isn't real time. So here we go, and you can see that already the orange simulation has crept ahead, and then once we get to this rotating section you can clearly see it's made up loads of time. So we're coming to the end of the simulation for the new GPU Core, 60 seconds, and the old core did it in 75. So with 501 frames for approximately a 60-second sim, the new core 15 seconds faster. In our next scene then, let's look at a much more simple setup. No fluid modifiers going on here. We've just got some particles, a turbulence, a rotate, and a color modifier. The particles are firing out 150,000 particles per second, and we've got this quite nice turbulent rotating sim going on. So again, on the left, blue particles, the existing core. On the right, the orange particles with the brand new NeXus Core. This is being played back at ×2 speed this time, but it's a simultaneous simulation. And you can see that our orange particles are definitely solving faster, just coming to the end of the sim. 501 frames in 26 seconds, and our current build in the blue finishes on 32. So in a very short sim, around 30 seconds, it is 6 seconds faster. And for our final speed test, let's have a look at this granular sim. Now this has got some different NeXus tools in action here. We've obviously got the granular solve with a NeXus fluids in SBH mode with this really nice cracking look. But we have also got a NeXus Question. Now the NeXus Question is using a field check and a speed check to switch between particle groups here. And then we've got our grains, and obviously we've got these 2 particle to object collisions with the floor and our bust model. So that is our latest one. Let's go into our test view to see which build is faster. So the same drill here. On the left, the current build with the blue particles. On the right, the brand new NeXus Core with the orange particles. This is being played back at ×3 speed this time, and it's a granular sim, quite computationally intense this, but you can see, look, visually you can see how much faster the new NeXus Core is. Just coming to the end of this 71 frame sim now, and we'll see it's finishing in 56 seconds for the new core, the existing core 66 seconds. So in a scene that's about a minute, the new core 10 seconds faster. The new NeXus GPU Core isn't just about speed of simulation though. The whole core is smarter and more efficient. We've got this less usage of VRAM, and it makes it a better, smoother user experience. Now this is quite difficult to visually demonstrate. When you use it, you will feel the improvements. But one thing that we can share with you is this. We're in the current build in this scene. We've got an X particles emitter. Let's make it a GPU scene by bringing in a turbulence and a color modifier. Now when I hit play for the first time, we've got a pause, it hasn't started, and then it begins. And it only happens once. On the second playback, we don't get that pause. If I bring in some more GPU tools, let's bring in a fluids and a gravity maybe, hit play. And again, look, we've got this first pause on first playback, and then it starts. And then if we hit it again, we no longer have that pause. And what's happening here is the GPU's being initialized, and it's preparing all of the GPU compute shaders that are required to do the calculations for these GPU effects. And it's a one-time deal. It just happens on first playback. A similar thing happens with the Maxon inbuilt particles, actually. Look, if we just switch all this off, go to simulate, bring in a basic emitter, hit play, and you'll see, yeah, look, we've got a pause, not playing, and then it starts playing, and it's a one-time deal. Hit play now, and those particles appear straight away. So it's obviously not a deal breaker, but it does hamper that kind of artistic flow. So let's have a look in the new NeXus Core at this same setup. So here we are now with the new GPU core installed for NeXus. Let's go and bring in a NeXus Turbulence, and we'll bring in a NeXus Color. So this is the first time playback and no pause on first playback. Let's bring in a fluids, let's bring in a gravity, hit play, and no pause. It just starts immediately. So that is just one example of how this more efficient and smarter GPU NeXus Core makes this a smoother, a better artistic experience. Let's have a look at some of the new features which appear across many of the new modifiers in NeXus. In this scene, we've got these particles, and what we're going to do is procedurally animate the radius of these particles. We're going to use a NeXus scale modifier to do that. Now, this uses the new layering system that we've showed in other tech previews. So what we have here is a set value layer, and it's setting the particle radius to 15 centimeters. If I reduce this, they get smaller. If I increase it, they get bigger. We've got some variation in here as well, so that is pretty self-explanatory. But what we can do with this is we can use new GPU Falloffs to drive these effects. So first of all, this new first layer, we're going to rename it and call it set value base, and these are going to be our base settings, basically our minimum size. We're never going to let the particles get smaller than this. Let's put it on maybe 2.5. That's a little bit small. Put it on 3 with some variation. Okay, that's our base settings. So now we're going to add another layer, and we're just going to do it with a set value. You could use some of the more intricate ones like the range, for example, but just to keep this simple so you can see what's happening, we're just going to use set value layers. And I'm going to double click on this one, and I'm going to call this one set value noise, and that's because we're going to use a noise GPU falloff with this layer. So because this is in normal blend mode at the moment, it's going to ignore the layer below, so it's just going to be, let's put it on 15 centimeters. So now it ignores that base, and we got our 15 centimeter particles. Let's not put any variation on just now, but we're going to go to our falloffs tab. Now these GPU falloffs have two benefits. First benefit is that they are a GPU tool, so they're really fast and efficient, much better than using the CPU Cinema 4D fields. But the second benefit is that we can have a fall off per layer, which is something you can't do with fields. So let's go to the set value noise, to its fall off tab, and we're going to bring in a noise fall off. Now these are cool because they use the INSYDIUM custom GPU noises that we've used in Turbulence and Color. So let's change the noise type to a smooth one, maybe cubic, and then the rest, let's just leave it in default and see what we get. So yeah, look, we're getting this animated noise is scaling our particles up and down, and because we've got these a push and attract modifier, we've got this really nice dynamic sim going on in the viewport. That's looking really cool. Let's just leave it on those settings. So if we go back to our scale settings now, go back to the general tab, at the moment we are ignoring our base level, but if we set our blend mode to, let's put it on max, now our particles are never going to get smaller than those base level particles that we set. So that's looking really nice. Let's add another layer. So we're going to add another set value, and this one we're going to put it on sphere. But actually, before we do that, I'm just going to switch that off, because let's add another layer of animation to this set value noise layer. We've already used a falloff to get this look, but what if we were able to procedurally animate this radius value that we set at 15? Well, we can do that with the new data mapping tools on a per level basis, which is huge. So let's go to the mapping tab. We're going to animate this value over the particle age. So let's go to the mapping tab, add an age map. And now look, we can select which layer we want to map. So what we want is the set value noise. The source we want to map, not the blend strength, we want to map the radius. And we want to map, the parameter we want to map is this one, the radius value. So let's find that parameter in our map list. Look, radius value at the top, that's easy. So what this is saying is, over a 30 frame period of the particle age, which is across the bottom here, 0 to 30 frames, it's going to map that radius value, and that is on this y-axis. So it's saying when the particles are born with 0 frames age, they have no radius value, and as they get older, the radius value increases up to full radius value at 30 frames and beyond. So let's see, the particles should have no radius, and yeah, look, then they scale up. Let's make it more obvious by going to our object. Let's switch this blend mode back to normal, and let's just put the radius size up a bit. Now hit play. Yeah, you can see the scaling up over 30 frames. Brilliant. Let's go back to our mapping tab. We've also added these clamp modes to our data mapping, which we've borrowed from the range layers that we've put in some of the modifiers. And this means that we can cycle some of these animation effects. So let's put this range up so it happens over 60 frames. And instead of it scaling up like this, let's have it, if we add a knot and pull this up, that radius value is going to scale up and then scale down over 60 frames. So let's just have a look at what that looks like. So they start small, scale up, and then scale down and disappear. So that's obvious. But if we put this on cycle, it'll just keep doing it over and over and over. So they're scaling up and scaling down, scaling up and scaling down. So that's looking pretty cool. I think we could reduce that to maybe 40 frames. Very nice. But our particles are now disappearing. Let's go back to our object tab. And now let's put this in that max blend mode so they're not able to disappear to nothing. Let's put it on max. Yeah, so we never get those particles disappearing, but they're scaling up and down. Cool. Right, let's add another layer then. So we did our set value sphere layer. Let's just take that capital out. That's better. Let's activate this. Now this is in normal blend mode at the moment, so this is going to ignore everything below just for now. And let's put this one quite high on maybe 28 centimeters. And now we've got these big particles. Let's put some variation in there. And we want this layer to have its own fall off. So let's go to its fall off tab, bring in a sphere fall off, and let's go back to the first frame so we can see it. There it is. Let's make this bigger with an offset that's smaller. So if we hit play, what we have got is the particles in the middle of the fall off have that full radius, and then it falls off. And if we move that around, obviously we get kind of this kind of animating sim because of our push and our attract modifiers. So that's looking pretty neat. If we want to mix this in with the rest of our simulation, we need to do the same thing. We need to go to the General tab, and we need to change the blend mode to max. And now, look, we're getting everything. We're getting that pulsing noise animation that's got the data mapping. We've got our spherical fall off. We could even add data mapping to the spherical fall off layer. Let's do that. So let's go to the scale. And what we want to do again is map this radius value. So with the value sphere selected, well, it doesn't actually need to be selected. Let's just go to the mapping tab. Let's add another age map. And in this one, we want to select that layer. Look, set value sphere. We want to map the radius. It's the same. It's the radius value we want to do. And let's do this over, let's do it over 40 frames. We'll do the same thing, but we'll just make it slightly different. Look, we'll have it scaling up slowly over 40 frames and then disappearing. And we'll put it on cycle so it repeats. So let's have a look. Yeah, look, so that's scaling up and then scaling down really quickly. Maybe slightly too quickly. Let's move it like that. And then if we do a different time, it's going to be slightly offset, isn't it? Or look, let's put it on maybe 20 and 60 to offset the scaling from the noise. Yeah, that looks looking good. And then if we move that sphere around, obviously it changes the position of where those particles scale up. So you can see from this demo that we can get this, we can use this as simply as you want, or we can make it much more complex with all of these different layers of both data mapping and modifier layers with Falloffs to get some really intricate control and looks. Let me just do one last thing to this animation. We're going to go to this NeXus color modifier. This too uses the new layering system, and at the moment we have one gradient by parameter layer. And what it's doing, it's colouring these particles, it's mapping this gradient to the particle radius. So small ones are blue, large ones are getting towards this kind of yellowy colour. But we can use our data mapping and our Falloffs on this system as well. So let's do that. Let's bring in another gradient by parameter layer. I'm just going to put that one on top. And this one, we're going to keep it the same, but I'm going to change the gradient to this orange gradient. Now this layer's on top. It's in normal blend mode, so now that's going to take over and ignore the blue. Yeah, so now we've got the orange gradient in there. Oh, it's set to speed. Let's put it on radius and put that on, say, 32. There we go. So now we've got that same gradient. Just going to move that spherical Falloff out a little bit, so we're just looking at the noise mostly. So now what we want to do is use this, want to mask this off with one of our GPU Falloffs, so we get a bit of blue and a bit of orange. So let's go with this top layer to our Falloffs tab. We're going to add a noise Falloff like before. Again, let's put it on a smooth one like cubic. Now this is cool, this is going to mix them, but because there's not much contrast in this noise, we're kind of getting a mix of the colours. If you wanted a very defined split of blue and orange, all you need to do, look, it's just add contrast to that noise by clamping the black and white. Yeah, look, and now we're getting really obvious bits of different gradient by parameter mixing. We can maybe increase the scale of that a bit, something like this. Increase the frequency so it's going to animate more quickly over time. That's looking neat. And then if we get our spherical Falloff, we can start bringing in that other bit of animation. So that is just a brief demo of the hugely powerful and new GPU Falloffs per modifier layer and data mapping per modifier layer too. Let's have a look at the improvements and new features then in NeXus Question. Now, in a moment, we'll jump into a much more complex scene and I'll show you some of the new particle neighbor search tools. But for now, we're going to stay in a really, really simple scene. And this is just so you can clearly visualize exactly what's going on here. Now, in this scene, there are two modifiers. There's a limit, which is locking these particles to this XY plane. And there's also a NeXus push, which is pushing them apart. But every other bit of animation that's going to go on from now, we're going to do just with one NeXus Question object. So in there, we already have two actions. Now, when an action doesn't have a question linked to it, it just happens all of the time. One of those actions is a set radius. So we're setting the radius of our particles to 70 centimeters, and you can see there they are. And we've also got a set color, which is setting it to this orange color. And we've got this on set once, so it sets them when the particles are born and doesn't try to set them again. And that means that we can change them later down in the timeline. We can change that color should we wish. So let's start messing around with this. First of all, we go to the set radius. We have introduced in all of the actions where possible variations, and that means that we can get way better, more organic looks using just question. So if I add some variation, 68 variation to our particle radius, obviously you're going to get those varied radius values. Pretty self-explanatory. If we then reduce the weight of that action, let's bring that weight way down, we're going to get this nice growth of our radius and they grow up. But obviously the problem is it's all too uniform, it's all happening at the same rate. But we have also added variations to the questions as well, which means we can get around this issue. Let me show you. So instead of just having this set radius firing all the time, let's have a question drive it. So we'll bring in a new question. And what we're going to say is this: if the particle age, we can leave that default, is greater than 50 frames, put the radius as the radius action as a child, and then it'll fire it off. So this is going to look the same, but it's going to wait until the particles are 50 and then they scale up. But with our question, we can put variation now in these in the parameter in which it's asking. So if I put that on 50, now we've got this massive variation, and we're all getting them starting their scaling up at different points. So that's looking obviously already much more organic. That's looking great. Let's add some variation to this color. Actually, we'll go to our set color, and look, we've got our RGB here. So let's just add, I don't know, maybe 0.1 and 0.1. And now we have got some different colors. Yeah, that's looking really nice. Okay, so now that we've got that, let's say that we want to fake these particles dropping with gravity, kind of accelerating with gravity. So we can do that. Let's do another question to start that off. And this question, instead of asking a particle question, we'll change the category to document, which is like the scene settings. And we'll keep it on time. So we'll say if the scene time is greater than 120, then do something. And we want to do something with particle speed. So let's add an action. And in this action, instead of setting the speed, I'm going to add to the speed, which will add to it all of the time, which is going to kind of give the feeling of an acceleration. So we're going to add, we need to change it from the default color to speed. Let's put this on maybe 70. So now at frame 120, those particles are going to start moving down. That's cool. Now they're all moving down at exactly the same time. So let's go back to the question, and look, we can just add a bit of variation like we did before. So add variation, and then that point where they start to drop is going to be slightly different for each particle. Yep, that's already looking much better. We could go to the speed and add a little bit of variation in that speed as well, maybe. Maybe not that much, maybe 30. Cool, so now we've got another bit of variation. As you can see, as we layer these up, the variation just makes all of the difference in making this feel like a kind of an organic sim. Let's get a color change going on. So what we could do is, let's ask a speed question. When they get a certain speed, change color. So we'll add a question. If the particle speed is greater than, 150 is probably okay. Let's add a bit of variation as well, just because we can. And then we'll add an action. This will be a set color. We'll change it to a kind of a blue color. And then, look, let's add a little bit of variation on all of those. Let's see what we get. Now, this is going to just snap to blue straight away, which isn't going to look quite right. So, look, let's reduce this weight of that set color, and then they'll fade to blue, and that's going to look quite nice, I think. So here we go. We'll start coming down with our fake gravity and then start fading to blue. Cool. Another thing that we're able to do with our actions is we can actually change this editor display mode. This is quite useful when you're kind of working out scenes, or especially kind of visualizing changing groups and the like. So look, with our speed question, let's get it to change its display mode as well. So we'll add another action, and in this one we want to set not the color but the display. Let's set it to planes filled. So this is going to look a bit weird now. It's going to work, but the planes are all going to be orientated towards the camera. So what we could do is we could add a little bit of random rotation here that's going to look like spinning. So let's add an action. We don't need a question to fire this one. We just want them to be rotating all the time. And we're going to add to the particle rotations. And we're just going to put some values in the variation here. So they'll all be spinning differently. Let's hit play. So we don't see the spinning when the spheres, obviously, but when they change into planes, then they spin and fall down. Cool. So obviously it's a really basic, simple scene, but you can see that just by using NeXus Question with our new variations in both the actions and within the questions, we're able to get these really cool, nice organic sims just by using this question and action system. And obviously, in reality, what you'll be doing in your scenes is that you will be using a mixture of modifiers, of GPU Falloffs, of data mapping, and questions and actions all mixed together to give you all of this amazing control over your particle sims. In this scene, we're going to have a look at the improvements and the additional functionality to the NeXus Question neighbor search options. So in our scene, we've got this Fox model. If I make that invisible and go forward a frame, you'll see that we are emitting these black particles from within its volume. And what we're going to do is create a kind of a melting effect from the surface inwards. We've also got, if I hit play, this particle stream coming from another emitter. I'm just going to switch that one off for now, and we're just going to concentrate on our INSYDIUM Fox. So we're going to use a NeXus Question neighbor search to work out which particles are on the surface of this volume. So the first thing we were going to do is we're going to add a question. And first of all, we want to stipulate which particles we want this question to be acting upon. And we want them only to be acting upon our Fox particles. So we're going to go if particle emitter, drag in the emitter we were asking the questions of. So let's drag in our emitter Fox into here. If the particles are with the emitter Fox, do something. So now we're going to ask another question, which is going to be a neighbor search, which will sort out which are the surface particles. So to do that, I'm going to go add another question, put this new question on and, so both of these questions need to be satisfied before whatever action we're doing is fired. And this one we're going to go particle neighbors. Now this is the new feature. What we're able to do in our neighbor search, we had this before, but now we're able to stipulate which particles from which emitter are we counting. Now we want the Fox particles to count itself. We want to find out how many neighbors each particle from the same emitter have. So let's drag in our emitter Fox into our objects, and we're going to say if there are less than, let's say, 18 particles, then do something. So I'm going to say, just so we can see what's going on, let's just put an action. Default, it's going to set the color. So the particles on the surface will have fewer neighbors than the particles in the middle of the volume. So let's hit play and see if we've got those numbers right. Yes, look, all of those surface particles have gone yellow and the internal ones have stayed black. If we want more surface particles, we can change that less than, say, 25, and now more surface particles are going to be visible. Let's put it back down to, say, 20, but we've got variations here as well, like we've got everywhere in NeXus. Cool. So now we have got our surface particles identified. Brilliant. But what we're going to do is not change the color. What we're going to do is change the group. And that is because what we have got in our scene is a NeXus fluids and a NeXus gravity object. But you can see that neither of those modifiers are doing anything. And that's because these two modifiers, the fluids and the gravity, in the groups affected, they've been set to only affect this group here, particle group fluid. And we haven't put any particles in this group, so nothing's happening. So what we're going to do is, in our question, we're going to work out what are the surface particles, and if they are a surface particle, put them in the group fluid, so then they'll fall to the floor and solve as a fluid. So let's change this set color, which we don't need anymore. Let's change that to set group, drag in our group fluid. So now if we hit play, we're going to identify the surface particles, and yes, look, they get put into that group and they start falling down with gravity and solving as a liquid. Excellent. That's looking really cool. All right. And you can see that because the question is asked every frame, on the first frame it works out what are the surface particles. They then get put into the group and they fall down. And then the next frame it reassesses the new surface particles and it keeps reassessing it. And so we get this disintegration effect, which looks pretty nice. So we're going to go one step further now. What we want to do is introduce our emitter stream particles, and we're going to ask an additional question. We're going to, let's go to our neighbors question, and we're going to add another question, because we want to say only put them in that new group if they're a surface particle and if they are near our stream particles. So in this extra question we've just added, We need this one to be and as well, and we want to move that set group action into there. And in this one, we're going to do another neighbor search, but this one we want to search the particles from the stream emitter, not the Fox emitter, so we can drag the stream emitter into this new particle search object window. And we're going to say if it is greater than, say, 5 centimeters within a 20 centimeter radius, then put it into that fluid. So if we move this emitter stream up so it's nowhere near our particles, none of these are falling down, and it's only when, look, a couple fall down here when it hit. It's only when they have enough neighbors that we get them getting put into that group, and then you can see these ones falling down into that group. So if I make this stream invisible, you can see that now we can start bringing this down, and we can start kind of directing where this surface disintegration is happening, because it's only happening when it has enough neighbors from our emitter stream to trigger it. So very nice indeed. That is how we can use NeXus Question with the new and improved neighbor search options to create and generate these cool disintegration looks. And that's just some of the new features and core improvements we've been working on with NeXus here at INSYDIUM. More tech previews coming very soon.